Welcome to Pipeline Conversations, a machine learning podcast by ZenML. This week I spoke with Robin Cole, a senior data scientist at Satellite View, a company that's about to launch a thermal imaging satellite into space in order to provide new ways of seeing the Earth from above. Robin generously took the time to discuss his day-to-day work involving satellite data, the stack they work with at Satellite View, as well as some of the difficulties that come up in the domain. We also discuss his extremely popular satellite image deep learning GitHub repo that presents resources for those working with or seeking to learn about this kind of data. Everything mentioned in the show will be listed in show notes as usual, and without further ado, here's the conversation.
I've got quite an interesting history. So my background is actually in physics. I did undergraduate and postgraduate studying physics and specialized in optical physics, and spent quite a bit of time as a researcher, both in academia and then in industry. And that was really a love of playing with, the laws of physics and hardware. Essentially, I remember being really into the laser labs that we had as undergraduates and thinking that's a really cool area of physics. You can see what you're working with. I want to work in that. And after academia, I moved to industry, and that was really good fun. That was basically building experimental systems, and there started to be a bit of coding involved in that. And actually, I quite enjoyed the buzz of like writing code and seeing machines move around and lasers blink on and off and all that kind of thing. And that sort of led me down this path from sort of pure science towards more software, and then increasingly also the analytics side. I've had a real fascination with the latest developments around artificial intelligence. It kind of sparks all that sort of childhood fantasies around sort of artificial machines that you could talk to, and I'm fortunate enough to do that now for my day job. So currently I'm working as a senior data scientist at a startup called Satellite View, and we have a satellite launching in the first half of 2023, which has unique capabilities. It's actually imaging in the thermal, which is a part of the spectrum which no other satellites are currently imaging in, or at least not commercial satellites. There's probably spy satellites that do it, but we'll be the first people doing it in the commercial area, and that is a really exciting position to be in. Startups, there's a lot going on, but you get your foot in the door nice and early. So for me, part of the attraction was to be literally, one of the first people through the door, being able to choose, the landscape of what tools we use, how we were going to build things, and set the stage for everything that comes after that. So it's been a really exciting place to be.
Mm-hmm. And what does the day-to-day work of someone in your position look like? What does that mean? Because data scientists can mean lots of different things.
That's right. I think data scientist is one of those job titles that probably can describe a very broad range of sort of activities. You could be in like e-commerce and looking at customer data, or you could be like myself and be basically working with images all the time. So to answer your question, my job at the moment is mostly R&D around actually processing of our images, which have unique qualities and potentially unique applications. And for the most part, we're scoping out the applications for that imagery. We're doing a series of short proof of concept research sort of cycles to, sort of identify promising applications for the imagery, demonstrate that we can extract whichever signal it is that we need to prove that, and then coming up with sort of pitch decks to demonstrate to potential clients the value of that application.
Yeah, I guess I'm wondering to myself, like, how you, if you say this is like the first time it's been deployed in this sense, like, or it will be deployed next year. Like, how do you develop the applications like before you have the data somewhat? But I guess you can do experiments with the
Right,
sensors
yeah.
on the ground.
There are some precedents for what we're doing. So there's already drone surveys and aerial surveys that do sort of some of the similar things that we're looking at doing. And actually, currently, we're capturing imagery on a plane. It's flying both in Europe and North America with what's called an engineering model of the camera. So this is sort of sort of a replica of what's going to be on the satellite, and we're capturing imagery already. So we're already capturing some
Okay.
data,
Right.
and it's really as simple as looking at the data, saying, okay, that looks like a really interesting phenomena that we're seeing there that potentially has commercial applications to such and such a sector. Let's speak with the sales team. They have their contacts and they can speak to potential customers for that data, and we have a bit of a feedback loop, obviously, where we try and refine a potential product around or solution around what we can see.
And I mean, obviously, within the limits of what you're comfortable with saying, but like, what are the kind of areas that this new sensor opens up? Yeah.
So one of the main areas we're focusing on is the built environment. So you're probably aware that residential property, commercial property, it uses an awful lot of energy just to keep it warm in the winter and even in the summer to cool it. And this is, a very topical problem around sustainability and sort of future economic and energy planning. So one of the areas we're looking at is, in particular, sort of studying the built environment to identify, say, inefficient buildings, buildings that are basically leaking heat and we can be identified for modernization or change of purpose or upgrade. So that's one of the key applications. There's also applications around just economic insights. People just want to know, are places busy? There's a lockdown due to COVID, for example. How many factories have ceased production? And there's lots of value in just that kind of economic insight that can be gained.
Yeah, it's been really interesting to see. I mean, I obviously only follow the kind of the very the big headlines which come out and so on. But recently there's been a lot being done on methane emissions, I think, from satellite data and so on. And yeah, it seems like that's only going to increase.
Absolutely. I mean, the unique capability of satellites is they can go anywhere. You can't fly a plane over some parts of the world and see are they emitting toxic fumes, but you can fly a satellite anywhere. So I think we're just started to see those capabilities come online, and particularly in the last couple of years, there's been a lot of innovation happening, and lots of it is funded by venture capital. In particular, that two things have happened. The cost of launches has come down dramatically. So SpaceX have taken the cost of launch down, and that opens up new possibilities. And so, and on the other hand, the hardware has got cheaper. So, for example, just to assemble a satellite and put a state of the art camera on there is much cheaper than it would have been, say, a decade ago. And this allows both investors and entrepreneurs to take more risks and more gambles and try out different kinds of technology. So something like the methane scanning satellite, it needs to be commercially viable, of course, and costs come down, and applications become more obvious, and suddenly those become viable commercial activities.
So to take a step back, and I don't know how far back a step we want to take, but just in terms of like the domain of data derived from satellites, let's say, like, what is this domain in terms of how we deal with it in terms of computer vision and deep learning and so on? Like, what are the problems you have to think about? Like, where are the kind of the key the key areas in this, and what does it mean to work on this data?
Sure. So, I mean, satellites have been capturing images of the Earth since the 1960s, and obviously the quality has improved over time, and the volumes of data have grown significantly. Historically, much of that data was analyzed by people, of course, literally rooms full of people poring over the latest imagery to identify what's going on in Cuba, or, can we, manually map out changes to the Earth? And obviously that's a costly activity, something that is not particularly fast and doesn't scale particularly well, of course. So the biggest developments, as far as I can see, in the last couple of years have been both access to data. So we started to see places like AWS and Google actually host very large data sets and make them publicly available, and also the availability of tools to process that data at scale. So, like I mentioned, if you wanted to do, say, detecting of a new road in a particular part of the world. Well, 20 years ago, that would have been somebody that had to physically look at the image and draw it out, whereas now we obviously have models that can detect those changes and automatically update maps on the basis of that. So there's a couple of big factors that have contributed to it.
Mm-hmm. And what are for people working in it in terms of your day to day? Like, what are the things that you struggle with? Is it the large volume of data? Is it the ways? Is it the fact that you need to bring data back and forth between where you're storing it in order to pass it through a training process? Or what are the kind of the problems there?
Yeah, just to address maybe the practical side of it. So even only about 5 years ago, I was working at a satellite company, and even then, data was basically residing on CD-ROMs within the business. It wasn't actually being shared around. It wasn't even archived and searchable, really. And so, it's taken time for the adoption of, say, cloud technologies and sort of scalable data stores like Amazon S3 to become more commonly used. And we've seen actually, those technologies become cheaper and understood and used by the practitioners who process this kind of imagery. There's been a lot of innovation, particularly recently, on the tooling around working with the data. So geospatial data or Earth observation data typically is not delivered, as a small PNG to your desktop, which you can open easily. They come in these slightly, I guess, proprietary formats, but it's basically a format called the GeoTIFF, which is a TIFF with specialized metadata that basically locates the image on the Earth. There's various headaches with that. So, for example, you can't just upload a GeoTIFF into your standard image annotation software because a desktop browser can't display a TIFF. You would have to convert it to a PNG or a JPEG. So suddenly there's these immediate hurdles to using this common sort of stack for working with images. There's other practical aspects like the size of satellite images. Individual images can be tens of gigabytes, right? So this is already at a scale way beyond what typical practitioners in computer vision would be working with. There's data homogeneity challenges as well. So I don't know if you're familiar with this idea of coordinate reference systems, but obviously the way you display data on a map, there's different sort of systems you can use to do that. And not all data or imagery is provided in a common system. It might be in multiple systems. So there's often lots of hoops to jump through just to standardize all your data sets into a common format where you can even begin processing. And even once you have it there, then you still have the challenges of the size of the data. So one of the things you commonly have to do is take a big image and slice it up into many small tiles and then process those individually, bring it all back together and assemble it into some sort of unified data structure. And all of that adds an awful lot of complexity. So yeah, lots of practical challenges.
You have issues with, this will tell you how much I know about how these images are taken, but like, is the image always like directly over? Or do you get like issues with like the angle at which the image was taken relative to the thing itself?
So this is the story of my life for sort of the last year and a half, particularly maybe not so much on satellites, but if you're capturing imagery on a plane such as we are, these are generally small planes that are buffeted around by the wind. They don't fly in perfectly straight lines. And so every now and again, you get an image that's perfectly looking down at the Earth, but more often than not, it will be slightly at some funny angle and you'll need to identify that. And an awful lot of the work that my colleagues and I have been doing over the last year and a half is about taking this noisy sort of raw data and then sort of standardizing it, performing various corrections to it to calibrate the imagery so they're consistent if they're captured under different conditions, for example, and then putting all of this into a standard data formats and making that accessible to basically internal customers at the moment, but obviously in the future external customers as well.
I can imagine that all of these challenges may also be kind of great drivers of innovation in kind of technological innovation in various ways. Just to have to deal with these problems, you have to, develop new techniques or whatever. Is that the case, or is it really? Is that innovation, I guess, being shared among all of the practitioners, or is it all kind of kept in house?
There's definitely a lot of innovation happening, and the best practice is moving very quickly. if you had looked at what was sort of published on GitHub and in the literature sort of 5 years ago, every single paper or team or repository would have a slightly different way of doing things, but actually over time they sort of standardized. And now, for example, you've got like projects like TorchGeo, which is part of the PyTorch ecosystem, which seeks to basically provide a common framework to work with geospatial data and really lower those barriers to entry. I'd say that the entire sort of availability of computing resources, over the last 10 years, we've seen the adoption of S3 for data storage, EC2 for processing of data, and the sort of easier access to sort of large clusters of computers for processing large volumes of data. That actually makes it much more practical to work with these data sets than it would have been, say, a decade ago. And many of those developments were not for geospatial, but clearly the geospatial can benefit
Right.
from them.
Yeah, and it sounds like there's at least as much in terms of firstly the problems, but also kind of best practices in terms of like the data engineering side as much as there is on the model development side in order to make this all work.
Yeah, I mean the model development side, I think that's obviously what we're here to talk about a bit today, but that's probably lagging the other areas, and it's not quite clear yet what the best practice is. There's been a couple of projects, for example, like Raster Vision is one that's maintained by an American company that basically try to provide best practice and tools for processing imagery, particularly using deep learning models. But I think with a lot of these new technologies, it maybe takes a bit of time for it to mature, or perhaps build up a sort of critical mass of users before you really get the benefits in terms of the usability and the sort of the ability of that tool to reach maturity quicker. So I think it's slightly lagging behind the other areas, but I'm confident that there's a lot of activity happening. And this will be sort of a solved problem pretty soon.
Right. Yeah, I can only just imagine. I mean, in software engineering, you have this kind of off by one era, and I think I can just imagine with like the satellite data and all of the problems you outlined earlier. There's just a dozen different ways where you could have kind of an equivalent of you formatted something in the wrong way, like the order of whatever coordinates, whatever isn't just right, and must be quite hard to unpack all of that sometimes.
Yeah, I think they're there, but obviously, really experienced people would know about all the little pitfalls and the gotchas. But
Right.
we need to lower the barrier to entry so that people who maybe come from a more general or machine learning background can start working with remote
Right.
sensing data rather than forcing everybody to become an expert in those.
Yeah. 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 So yeah, I'm interested to kind of talk about your stack, like your process. How do you deal with all of these images that you have to deal with? What does that look like in your case?
So as I mentioned, I was the first hire, and I had the sort of the opportunity then to build from scratch. And actually, in my previous role to this one, I was working as a data engineer at an e-commerce company, and so I brought many of the ideas and tools that we'd used in that role to apply to our current data. So, for example, the data that we capture on the plane flights actually gets returned as these single, very large binary files that then need to be basically accessed and individual frame data captured from them. So I basically did what I did in my previous role, which was to start with AWS Batch, which is a service, obviously designed for batch processing, and it essentially allows you to write Python scripts and run those at scale. And what I found was that, yeah, it works and you can process large volumes of data quite quickly in parallel in that way, but it's not necessarily the most user friendly once you become, like, say, the data, you put your data scientist hat on, you want to start using some of the processes in there. So, what I found, in particular, was that many of the way the sort of the variables that you use to calibrate your data, they needed some fine tuning. So I needed to do some experiments really to identify what was the best way of processing our imagery. And if you have everything in a single massive batch job that runs for an hour and then gives you a result. That's not really ideal for experimentation. So the next thing I did was actually to break out sort of chunks of the processing into Lambda functions, and this sort of evolution moved from having a single batch job that did an awful lot of things to having a batch job which actually was just coordinating several different Lambda functions, each of which could then be accessed outside of a batch job for experimentation. That has a couple of sort of advantages. For example, like you can access just that individual chunk of the processing anytime. It's just a Lambda function. You can use it in any other analytics application. It isolates parts of the processing code. And actually, I did find some funny issue. Originally, I was using matplotlib, right, to create some visualizations, but I found that if I tried to save a file in matplotlib 5,000 times in a loop, essentially, that you get these funny memory issues, which are very difficult to resolve. But actually, if I just called 5,000 Lambda functions, each one just did that one time, I didn't have those same issues, and it actually reduced the sort of cognitive burden of doing some of the processing. So there was a couple of advantages there. The sort of evolution from there, once you've basically got the processing happening in Lambda functions, you don't necessarily even need a batch job or a Python process to manage that. You can, for example, use AWS step functions, which don't require you to run any server whatsoever, and they can actually manage the calling of these Lambda functions. Or you can set up other kind of situations where events on S3, say, would trigger a Lambda function. So you could, say, drop in a file that needs some sort of calibration into one bucket that would trigger the Lambda function, which would know to create the calibrated image in a second folder.
Have you found any limitations to working in this kind of serverless workflow, that kind of where you don't really have anything doing the orchestration particularly? It's just like things are chained together.
So I did, yeah. There's some obvious, well-known limitations to Lambda functions, like the time that they can execute for. So 15 minutes sounds very generous, but for some of the processes that we got, actually, particularly if you're working with large numbers of images where you need to extract statistics from them, actually that becomes a bottleneck in itself. So there's obviously a time limit there. I did find some other issues around sort of the practicalities of using lots of Lambda functions to access, say, resources on S3. So there are limits, like how many times you can access a file on S3 concurrently. And I discovered those pretty quickly when all of my Lambda functions were calling the same calibration file on S3. And obviously, there's just the management side. So you go from having, say, a single batch job, which is maybe, say, a single Python script, essentially, to having maybe a single process that's calling maybe 5 different Lambda functions. And if you're not careful, right, and bugs can be quite difficult to track down across that sort of distributed processing space. For example, like subtle bugs to do with like data types changing and not being appreciated, and then maybe you have this whole pipeline to sort of try and debug rather than necessarily being able to just jump into a single sort of Python interpreter and resolve.
And how are you getting the individual tasks up to the Lambda functions? Like, are you Dockerizing something? Like, how does that work?
Yeah. So I'm a big fan of Docker, and actually I was quite lucky to start using Lambda functions just around the time that they supported using Docker. I think prior to that, you basically had to like create zip files and upload them somehow. But I've been using Docker for a while. Lots of sort of side projects have used it prior to this to sort of create little web apps and things like that. But particularly if you've got several people working on a piece of code, the ability to sort of standardize on Docker somewhat simplifies the situation. In our team, we've got a mix of Mac users, Windows users, and one guy on Linux. So getting a consistent environment for all those people can be quite challenging, but actually using Docker helps to standardize that. And I was quite pleased with the approach that I settled on for creating the Lambda functions, but I was using dev containers with VS Code, and you basically develop inside a container. And once you're happy with it, I had a GitHub action which would then build the image and push it to the container registry on AWS. And the action was set up so that on new releases to that repository that would happen. And then the process I had was actually just to go to the AWS console and say, hey, there's a new image available. Let's use that. But of course, that could also be automated, or there's other tools out there to manage this process for you as well.
And you basically living in and interacting with Python, or are there other languages involved as part of this whole process?
So personally, I'm just using Python, but particularly with some parts of the processing chain, there are legacy tools that need to be used, and these might be written in other languages as well. But yeah, luckily I don't deal with those too much myself. But yeah, so we do have lots of stuff, a couple of pieces of software running on virtual machines that then you have to create an interface to those as well. But for the most part, everything is Python.
Okay. Yeah. So, and you can kind of, I guess, yeah, that's enough to be able to put a wrapper around everything and put it into your workflow the way you want
Yeah. And of course, the beauty of Lambda, it can support multiple languages. So if for some reason there was some processing that needed to happen in Java, for example, you could just use Java in your pipeline as well, and in that particular Lambda function sort of workflow. So it actually gives you a lot of flexibility. Another benefit I should mention is the ability to isolate your environments. And this is quite relevant to the geospatial domain because there can be some quite funny dependencies that come in, and you can get lots of weird conflicts. So the ability to just isolate different parts of your processing chain, it's fine. We're not gonna break that bit or do something by updating dependencies somewhere else. That gives you a lot of sort of a bit of a safety net, I think.
Mm-hmm, mm-hmm. And how does that? I mean, does this encompass the whole, I guess, experimentation process? You mentioned you're building a bunch of kind of small MVPs of various things. Like, how does that work with training models and so on alongside?
So for the modeling work, typically the kind of MVP that we want to do is to demonstrate a sort of a basic service, like an API, essentially. And so the current workflow that myself and the other researchers has got is you can do what you like, right? But eventually you need to package it up and put it behind an API somehow. And so actually, Lambda is the way that we've been doing that, of course. There's quite a lot of flexibility, like I mentioned earlier, we use Docker, so you can create an environment that's isolated, you know exactly which dependencies you've got. You can train your model in that environment if you want, although we often use cloud machines for that as well. And then as long as it gets deployed to a Lambda function and has an API in front of it, then sort of MVP requirements are met. And typically at that point, we'd hand it over to the engineering team who would do the things that they need to do to make it more robust. But in a startup, you got the lines are quite blurred. So sometimes we'll find ourselves doing a bit more of the engineering work than other times.
Yeah, from my own much more limited experience, definitely for some reason computer vision tools seem far more prone to weird dependency conflicts and just a whole bunch of stuff around deploying and converting models and so on. You often hit these really painful things that you just
yeah. My personal pain is compounded because I was one of the early adopters of the Mac M1. And so, things just didn't work on it to begin with. And then you've got Docker, which runs, I think, in emulation on it as well. Computer vision, it does bring a lot of funny dependencies in. So, for example, like OpenCV is used by an awful lot of libraries for loading images and performing operations on them. And that is obviously written in C++. And, I've had various issues where for some reason it works in Docker on one machine, but not in Docker on another machine. And there's inevitably some extra steps you need to take to get things working. I'm a bit envious of the people that can just use sort of pandas and scikit-learn for everything because that looks way more straightforward.
Yeah, it definitely feels like particularly things around OpenCV, not to pick on any particular library in particular, but there could be huge compound benefits for fixing those underlying nagging issues. I feel.
Yeah. And I think, again, that's one of the areas where Docker can help. So, for example, like somebody can create an image, it's got everything you need in it, and you just need to add what additional parts you need to it. And, we can get an engineer to refine that, say, and then the data scientist can come along and use it.
And speaking of just tooling, like what special tools do you use? Special favorite libraries? What kinds of things are you using as you do your day-to-day work?
I mean, most of it is probably familiar data science stack. So I use VS Code. I use Jupyter notebooks inside that for lots of my sort of R&D activities. As I mentioned, we use Python and Docker as well. Uh, most of the time, my imports would be something along the line of import NumPy, import Pillow. We also use a mixture of PyTorch and TensorFlow as required. Um, so for the most part, it's familiar stuff. I mean, I think like computer vision is becoming much more mainstream these days. So I definitely feel like the tooling and the libraries around it are much more user friendly and fully featured than they were even just a couple of years ago.
And are you mainly? It sounds like you are, but are you mainly kind of hanging out with open source tools, or is there anything kind of custom or
Oh yeah,
proprietary you need specially?
for the work that I do, it's all open source. We do use some sort of proprietary tools for some aspects of the data processing, but actually not particularly touching the images that I work with. So, for example, like where we create these large mosaics of images, that's done with proprietary tools. But for the data science work, it's all open source. We're big believers that open source software has the most users, has the most eyes on it, actually results in the highest quality. And I really can't see a situation where we would use anything other than that for the data science work.
So you've got these open source tooling that you're using. Like it's definitely there's a ton of almost every day you hear new things which are being done in terms of the research work on in computer vision in general. How much? Obviously, you're a startup, so maybe you don't necessarily go down every rabbit hole, but like how much of that do you follow and you feel you need to keep up with for your day-to-day work, or is that not really so important?
Uh, I find it a very interesting and fascinating topic. I try, and try and put in say half an hour a day just to check. There's a couple of journals that I check just see what's there, and stuff just pops up in your feeds as well. I find that an awful lot of stuff just is presented to me on say Twitter or GitHub uh, that we immediately find useful. We have a couple of areas that we're particularly focused on right now, which are our highest priority, and so we keep a closer eye on those areas. But yeah, there's an awful lot of material happening, not just in the remote sensing computer vision world, but also the wider computer vision world. So there's a lot of work, for example, happening in teams that are working on autonomous cars that is very relevant to what we're doing as well. So we have quite a broad focus in terms of keeping an eye on what's coming, but it's a lot. It's a challenge.
And I guess I mean the whole transformers multimodal models story, like is that kind of infringing onto your attention as well increasingly?
I hope that we'll get to that point soon. We're still basically doing quite, I'd say, more bread and butter sort of computer vision work. Basically, we're still solving a lot of the sort of foundational challenges around image quality and but yeah, that more exotic stuff and where a lot of the innovation is happening, that's obviously where we hope to get to once all this work is done.
Nice. So you maintain a super popular GitHub repo, the satellite image deep learning repository. I'm kind of interested, just if you could tell a little bit about the backstory behind that. How you came to start working on that.
Sure. So this was I started this in a role 2 or 3 roles ago when I was actually working as a scientist. Basically, I was working on the optical design and characterization of telescopes to go on satellites, a company called Surrey Satellites, and I had a couple of days just to do some blue skies research, and I said I'm going to investigate artificial intelligence and what we can do with that to help catalog the imagery that we've already captured. So I spent a couple of days just working on a basic classification task using TensorFlow 1 at the time. And what I discovered was there was just very little material available to help you uh, start working with remote sensing data using deep learning tools. I mean, I think when I started this repository, there was probably about 4 or 5 references on it, and there really was just not much to be found. So I kind of started this as a cheat sheet to myself, and didn't really think it would ever get much interest outside of a very small niche. But I think what we've seen is that a lot more people outside of the classic remote sensing community are interested in the data, and that is reflected in the popularity of this repository. I think it was at like 20 stars for the first couple of years, and then probably went up to a couple of hundred. But I didn't really notice it until maybe I started my current role, which is only a year and a half ago, and then it's really taken off since then.
It's over 3,000 or something now, I think.
That's right. Yeah.
Yeah, amazing. Yeah, and it's definitely approachable, I would say, to non experts in the field. Like that's what I've enjoyed. Like it's depending on whatever specific use case or whatever, there's it seems like there's increasingly like an example for everything, and find it really useful for that.
That's right. Yeah, I think when this repository started, like the examples were like 200 lines of code, and now it's like import PyTorch, and 5 lines later you've got a prediction. So definitely, it's got a lot more user friendly, and I like to think there might be a feedback loop where the more material that is available will help
Right.
people get to those efficiencies that much quicker.
Mm-hmm. And how is the space in terms of access to open data sets at the moment, like in the remote images domain? Has that changed a lot? Like are there free data sets available for people to just get going with?
Yeah, I think definitely. I think I mentioned earlier on that like 10 years ago, lots of this data would have been very hard to access. I've even heard about people like sending requests and getting DVDs through the mail. Right? But now you've got like Google Earth Engine, which is an incredibly popular platform maintained by Google, where you can literally log in and just access like hundreds of different kinds of data sets and immediately begin like visualizing and computing on those. I think maybe one of the challenges right now is that these data sets are spread on lots of different platforms and maybe just not well known. This is one of the other things I've tried to do with my repository, is actually just create a place where you can actually just search for things. I want to say find a cars data set, like you wouldn't necessarily say, okay, I'll go to Google Earth Engine. It will definitely be there. It might not. It might be in some academics
Right.
Dropbox somewhere, and only 5 people in the whole world know about it. So I think the data is out there, but the discoverability is a challenge. I think the other side of it is you don't just want raw data; you want annotated data, and we've seen, particularly in maybe geospatial world, that the annotations can come in many shapes and forms. So hopefully over time we'll see both the creation of the right kinds of tools to standardize those annotations, and maybe a convergence on particular kinds of annotation formats that will greatly simplify the use of these data sets.
Yeah, I was going to ask if there were like meta search engines or like interfaces where you could say, I mean, I assume many of the kind of big name intelligence agencies have these kinds of things where you have a specific coordinate and you want to be able to scroll through all of the images available on different platforms for a particular day, let's say, or I guess you're saying that we're not there yet.
We're getting close to that, actually. So that in the last 2 or 3 years, there's been a lot of work standardizing the way that these data sets are presented to search engines. And there's this sort of format called the stack catalog, which basically says we're going to index geospatial data in a standardized way to make these searches much easier. And then, we can provide a single search location to query all of these basically on, dimensions of time or space. like any new format, it takes a while for it to sort of settle down and to become sort of accepted, and all the data sets to be prepared and put into it. So I think we're close, but it's not quite there yet. Um, and yeah, there's a couple of like general purpose like resources out there. Like I found that Papers with Code, for example, has links to lots of data sets, and then there's lots of some of the so for example some of the image annotation platforms also host data sets. So I've used RoboFlow a little bit, and for example that has a data set catalog on it where you can query. So I think we're there, but yeah, there's a bit more work on the standardization and just the discoverability to do yet.
Interesting. Um, I'm curious if there are some kind of things which you do in your day to day, particularly in the context of a team, maybe around this particular domain of data, which yeah, where you've kind of learned some best practices. I'm thinking, particularly kind of anomaly detection and error detection around like build it when you're building your models. Like for computer vision, this is often like can be quite a visual thing, and like you'd like to like refer back to, I don't know, the overlays of things that you're detecting on top of images and so on. Are there things that you do like regularly around that which you found super really valuable?
Yeah, I mean, it might sound a bit mundane, but we use Slack to share interesting insights. So, for example, I'm on the R&D side, but we have people that are more on the analytics and analysis side who actually spend a lot more of the time actually looking at the imagery, and they often spot unusual things that I just wouldn't notice just because I don't spend that much time looking at the imagery. And just having that channel of communication where you can share insights, I think, is really useful. Um, People finding unusual things in the image that we need to know about before we create models is really important.
You brought up kind of annotation there. Like, is annotation like part of your workflow? Do you outsource it? Like, is that yeah? How do you handle that?
Yeah, so essentially, if there's annotation that needs to be done, then whoever's
Right.
working on the research project has to do it, which I think has benefits, right? Because you actually spend more time getting hands-on with the data, and you also have to be smart about working with the data. So we've done some R&D activities using a tool called Lightly to try and understand the distribution of sort of our data set and understand, which parts of a data set even need to be annotated or have the most unique characteristics and therefore should be, prioritized for annotation. And yeah, it takes a certain scale to get to the point where you can actually outsource annotation. So if you go and speak to an annotation company, they'll say, "Oh, how many millions of images have you got?" And if you come back with a number that's not millions of images, they say, "Okay, sorry." So it's kind of like driven on both ends. That I think it's worth doing to some extent, but also you need to be at scale before you can outsource a lot of this stuff anyway.
And are you using just standard open source annotation tools, or are there special things for satellite data that you need to use?
It's a bit of a mixture at the moment. There's no ideal tool. There's obviously lots of annotation tools out there. If you narrow that down to the ones that support geospatial data, that list becomes very short. And if you narrow that down to the ones that work with our kind of single channel thermal imagery, the list is vanishingly small. So basically, it depends on the task at hand. Either pre-process your imagery into the format that can be used on a standard tool, so we lose all the metadata around where the images are. We just have PNGs that are contrast stretched and resized, and just put that through Label Studio. Or, and actually I was doing this morning, you create your own tools where you can actually work with the geotiffs as is and annotate on those. So perfect tool does not yet exist, and I think there's always that build or buy trade off that you have to decide based on how niche your application is, and I think it's going to take a bit of time to figure out where exactly we sit on that build versus buy.
Yeah, definitely seems like at certain scales and certain applications, people just end up building their kind of own annotation, custom annotation platform, and that yeah, I mean, like you said, there's a million and one annotation tools available, particularly in the kind of closed source realm, but no doesn't seem like there's a kind of a clear standout, very flexible and extensible tool which allows you to do anything. Yeah.
I think the way I'd like to see it go is that we wouldn't build a tool, just for our own purpose. We would ultimately contribute to an open source tool. And I think, for example, is it Diffgram? I saw they support like annotating synthetic aperture radio imagery, and that obviously is being provided by a company that generates that kind of imagery. And I can see that maybe we would do the same thing for thermal imagery in the long
run. So we usually end with a kind of a couple small questions. Interested to hear your take, given your background. First one, what would be kind of a quick win that, in your experience, you think would be useful for someone to make their productionizing of models more robust?
So my answer to that is validate the data that you're inputting to the model. So I've seen this myself, where I've created a model, I'm very proud of it, and I put an API in front of it and I show it to a colleague, and immediately there's issues because actually the formatting of the data is ever so slightly different from what I was expecting. And so a bit of time up front just to validate the data, the quality of the data, and the format of the data can save a lot of pains later on.
The speed at which you answered that suggests that you've been burnt by that. Yeah, for sure.
Oh yeah.
And what would be kind of one part of putting models into production that you think is neglected by tool makers in the space, in whatever area, I guess?
So I've got two answers to this. The first one is around like the optimization of the actual inferencing experience. So particularly for vision models, there's several different strategies. You can compile it to some other format and actually get like a 10x improvement in the rate of inferencing. But that's quite specialist work. And let's say as a data scientist working on the model, that maybe doesn't fall in your camp. And as somebody on the ML engineering side is maybe a bit too specialized, it doesn't fall in their camp. It's sort of in the cracks a little bit. So it'd be quite nice to see that supported. And I would also there's a second part to that, just to say, can we please see more support for vision data? Because nearly all the tools out there basically focus on, text data or tabular data. And vision is like a footnote somewhere. So please can we have some more for the vision people?
Nice. Well, yeah, thank you very much for coming on. Definitely been really interesting to hear this kind of use case and your experience working on it.
Thank you, Alex. It's been a pleasure to be on.
Yes. Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.